Hello, this is Ahmed Al-Hadrami. This presentation is for course ME 496. Video assignment for this problem statement. Stating gate AB extends 1.2 meters into the page, has mass 180 kilograms, hinged at point A. Glycerin and water are at 20 degrees Celsius. Water is continually added to the right side of the tank. At what height h will the normal force equal 0? Our problem statement here wants us to determine the height h when the normal force at point B is 0. The normal force as B. The normal force is perpendicular to the surface. What does it mean that the normal force is 0? It means that our gate AB is at the verge of opening. If our gate would open, this is our hinge, so it would open along this direction. Let's look at our diagram here. We are dealing with a submerged scenario. We have a submerged surface, our gate AB, submerged between two fluids, glycerin on the left side and water on the right side. We know that forces develop due to fluids in contact with the surface. So we will have a pressure distribution acting along this entire gate or the entire surface, caused by the glycerin, and we have another one caused by the water. We would look more into the pressure distribution in a moment. Let's establish our axes and dimensions. We do know that we're dealing with an incompressible fluid. Most fluids are incompressible, and we have a static system. And we said we are dealing with a submerged scenario, a surface submerged under a liquid. So this leads us to the principle of hydrostatic forces on a plane surface. Our surface, in this case, AB, is an inclined surface, angled at 60 degrees. The angle theta is the angle between the inclined surface and the free surface. And we have this length, 1 meter of the gate. Remember, we do have, we are given that the gate extends 1.2 meters into the page, or we can think about it as in out of the page, 1.2 meters. So if there was an eyeball, we would view the gate from this angle and it would look something like this. So our area is 1.2 times 1, which is just 1.2 meters squared, is our area of the gate. And another important axis to establish before tackling the problem is the center of gravity of the gate, our surface. the geometric center of our surface, or our centroid of the surface, is half the base, because our geometrical shape here is a rectangle. Let's call this our centroid axis. There is a very important distance to know here. The distance HC is the distance from the free surface to the centroid of our gate. Let's make this in green. And another vertical HC distance for the water. Now we do know that our H value is nothing but HC plus this distance, and this distance right here we can find out because we do have the angle. Or angle theta, and because we want just this part of the vertical distance, we're going to use half of the entire length, so that is 1/2. This makes our vertical distance 1/2 sine 60. And now let's explain how the pressure distribution is acting on the surface. We know we have a pressure at point A. We know we have a pressure at point B. So if we would draw our pressure distribution, it would look something like this. We would also have pressure distribution caused by the water, and this is caused by the glycerin. We'd also have a similar shape because pressure increases as depth increases. So pressure and length are directly proportional. We also know that if we do the total sum of the pressure acting on this entire surface, we are gonna get the resultant force. Our resultant force acts under the center axis, the centroid axis. Do call this FR glycerin, FR of the water. We can't tell yet which resultant force is closer to the centroid axis, but we will find out in a few minutes. We are going to draw the free body diagram in the next step, but before that, we do want to know that our interest for this problem is to find our magnitudes of our resultant forces and the perpendicular distance from the resultant force, and that will give us all the distances so we can take the moment about a point and find our distances. We will start by drawing our free body diagram. We know our reaction forces at the hinge. We know we have a normal force. Our centroid axis is the same axis. This distance is distance YC. We will have the weight force acting at the centroid. And we will have the resultant force for the water and the resultant force for the glycerin. And to determine the magnitude of our resultant force, we will use the equation FR equals area acting over pressure acting over the area. We know pressure equals specific weight times height, and we do know that HC is also YC sine theta times A. Separate this. So we are going to use this equation to find the magnitude of our resultant forces. Our resultant forces is the summation of pressures acting on the entire surface. We did mention that earlier. And now we are interested in the resultant force. Let's start with the glycerin. Our specific weight for glycerin is 12.4 kilonewtons per meter cubed from table 1.6 for the physical properties. And our height HC for for the glycerin is 2 minus this vertical distance. We said this vertical distance is half sine 60 because we do have a triangle here, and we know the length from point B to the centroid is only 1/2. So HC equals 2 minus the vertical distance times the area. Our area is 1.2 meters squared. I did the math earlier to save time, and our value for the FR 23,317.771 newtons. And now we're gonna find the resultant force for the water. This is 316. We'll box this because it is an important value. Next, we're gonna find the resultant force for the water, and our specific weight from table 1.6 is 9.8 kilonewtons per meter cubed times HC for water is going to be H minus the vertical distance. So we did say here H is HC plus the vertical distance. So now we want to use HC. So HC is H minus sine theta. We just took this to the other side. Times the area. And this comes out to, actually I would rather have this as one term so we can have a cleaner number. So if we would leave our distance HC as HC of the water, our resultant force is going to be one. We finished with the 1/3 of the problem, which is finding the magnitude of our resultant forces acting on each side of our surface. We did say that our distance YC for the glycerin is 2 minus HC. Sorry, 2 minus the vertical distance. And we did say that our vertical HC for the water is H minus half sine 60. And those are our magnitudes. Now we would like to find the location of our resultant forces using the equation for location of hydrostatic forces. Should I do this here? This equation was found by combining the magnitude of the resultant force and the parallel axis theorem. We did mention earlier our magnitude of the resultant force is the summation of the differential pressures acting along the surface, and the parallel axis theorem is substituted with the magnitude of the resultant force equation. And there is a tricky part in this equation that it depends on the case. It is not always as tricky. These two YC values are not the same value in this case. Our YC, the first YC value is our center of gravity of the gate. So you just do CG, and our YC in the denominator is H minus H over sine 60. So our IXC is over 12 AB. No, this BA, because we are trying to find the Y distance. So this is with respect to an axis passing through the centroid and parallel to the x-axis. And let's take a closer look at what I mean by the distance of the center of gravity of the gate and the distance of YC to the free surface, from YC to the free surface. We'll start with the center of gravity. We have point A here and point B right here. This is our gate, so our center of gravity is half the base because it's a rectangle. You know, this is 1, so this is just half. And for this case, the YC in the denominator, we are now dealing with a different height. As we can see, we know HC is the vertical distance. HC is the vertical distance to the free surface. This is HC. So let's use a different color. This is our HC, and this is our centroid of the gate. The denominator term is the length from the centroid to the free surface. And to the free surface. And we do know the angle, and we do know HC. We do not know HC for the water, but this is the main difference between the two YCs. The first one is the center of gravity of the gate, and this one is from the centroid of the gate to the free surface. Let's start by finding the perpendicular distance and it is a perpendicular distance to the resultant force. The location of the resultant force is also called the center of pressure. So the location from the resultant force is perpendicular and we would start with the glycerin. Our centroid of the gate is 0.5 plus our second moment of inertia is our base is 1.2 and our height is 1 cubed. We did say we know our HC value for glycerin. It's 2 minus the vertical distance. This is our HC value, and we want this distance, so we would subtract the vertical from 2. Over sine 60 times the area. And this is the location of our resultant force. This value comes out to 0.54606. This is also an important value. Let's find the YR distance for the water. And we don't know the HC distance for the water. So we know our HC distance is equal to H minus half sine 60. But to have a cleaner term, we would keep it for H now. We will keep it as HC and solve for H at the end. C over sine 60 to sine 60 times the area 1.2 meters squared. And this value comes out to this is also a very important value. Those two are our perpendicular distances. And at this step, we are ready to take the moment about a point and solve for our missing distance. So I'll take the moment about point A, so we can neglect the reaction forces at this point. and our weight will have a perpendicular distance from point A of half cosine 60. We know this angle is 60 degrees. We know this angle is 60 degrees. We know this whole gate length is 1 meter. So the centroid, it's one half. That makes this 1/2 cosine. Our perpendicular distance is gonna get pushed anti-clockwise, so it will be positive. We will write weight as mass times acceleration times the perpendicular distance and then our force from the water is gonna cause an anti-clockwise, a clockwise rotation, that's a negative, times the perpendicular distance. Let's show the perpendicular distances on our diagram that we found out using the equation involving the second moment of inertia. We found this distance, YR, the location of the resultant force, and we found this distance, the location of the resultant force formed by the glycerin. So our perpendicular distance for the water, calculated as 0. And then our resultant force caused by the glycerin is gonna cause anti-clockwise rotation, making it a positive. Multiplied by the perpendicular distance calculated as 0.54. And we will plug in the values for our magnitudes of our resultant forces. Our mass of the gate is given to us. And we did say it is and the FR for the glycerin times the perpendicular distance. We will solve for HC and we get this value to be minus 441.45. Is a positive number, and C, and solving for HC, we get HC equals 2.529 meters. So our height h is hc. Oh, I hope that was viewable by the camera. Our distance h is hc plus the vertical distance, and we found our hc value plus 1/2 sine 60, giving us I mixed up the numbers when I was writing the values or answers. I did the math earlier to not do it during the session. So this is 2.096 meters. Sorry about that. And our final answer is 2.529 meters. This is our height h measured from the free surface to the bottom surface. So all we did here is a little bit of geometry and determining the magnitudes of our resultant forces and the location of the resultant forces. And we took a moment about a point, equilibrium state, and those are all the steps that are used in this problem. I hope I covered everything. We did say that these two YC values should be distinguished. They are not the same number, as we explained here. The YC value is from the center to the free surface, and the first YC value is the center of gravity of the gate. And we did say that when the normal force is 0, the gate is at the verge of opening. We also did mention that YC is equal to HC over sine 60. Yes, I did show that here. And yes, I hope I covered everything. And for verification, this is me, Ahmed. Thank you.